Okay, this one. Okay, I'm going to explain this question now. This one. The resistivity. The resistance is equal to resistivity multiplied by length divided by area. So by this in this formula, you can guess, right? The resistance is directly proportional to the length. It means if the length increase, resistance will increase. If the cross sectional area will increase, the resistance will decrease, because this is inversely proportional. So fuse is made up of short length. So if it is length is short, what will happen? Resistance will be less, right? They are talking about. Explain why fuse of higher rating are made of thicker wire. So why it is made up of thicker wire? Because resistance is inversely proportional to the area. Okay, resistance of thicker wire is lower, fuse will melt. Okay, the resistance of thicker wire is lower, the fuse will melt. Okay, there. Okay, if the wire is thick, then the what happen? The resistance will be what? Fuse will melt. Lower the fuse will melt means less the fuse will melt. Okay, at high current, because heating effect is I2 by R. Okay, if less heating effect for the same current, what does it mean? So here, see here, don't get confused. They are saying if the length is short, a fuse is made of short length, but wire is thicker. Length is short, but the wire is thicker. Okay, so it means less cross sectional area. If the less cross sectional area, there will be more resistance. Because resistance is inversely proportional to the area. Okay. So if the wire is thicker, if there is more cross sectional area, okay, if the wire is thicker, it means there is more cross sectional area. So if the more cross sectional area, resistance will be what? Less. If one increase, other one will decrease, right? Now area is increase, resistance will decrease. If resistance is decrease, then what will happen? So if the resistance is lower, fuse will melt at higher current. Fuse will melt at what? At higher current, if the current is high, right? So what does it mean? When the resistance is more, what? With the if the resistance is less, the fuse will melt at higher current. Why? Because the heating effect, the formula for heating effect is I2 by R, right? Okay, look at this question. Shows a 12 power supply connected in a circuit. Circuit include a lamp, a resistant wire AB of constant cross section area. Okay, the area is constant, means it's not change. Okay, the sliding contact that can be moved between A and B. The rating of the lamp at normal brightness is this. Okay, at normal brightness voltage is this, and the power is this. So now they they are saying to find the current at normal brightness. So you know the formula P is equal to IB. So you know the power of the lamp, you know the voltage of the lamp, and you can very easily find the current of the lamp. The resistance of the lamp is V is equal to IR. With this formula you can find the resistance of the lamp. Now we have resistance of the lamp, now we have current of the lamp at the normal brightness. So now they are saying the AB length, this AB length is 1 meter and it has a resistance of 5. The AB length have a resistance of 5. Now the lamp has a normal brightness when the sliding contact is at X. So when it is at X, or when it is moved from A to B or B to X, at X it will have normal brightness. When it will have normal brightness at X. This sliding contact is moved to B. Explain without calculation why the lamp get dimmer. So when it is moved at B, the lamp will get dimmer. Why? Because resistance of the wire is greater than at X. Because the resistance when it is moved at B, the resistance get higher. When the resistance get higher, when there is no more resistance, there will be less current, right? There will be less current. Because V is equal to IR, if R increase, there will be I will decrease. Okay. Calculate the distance X for the lamp. So you have to calculate now distance. What is the distance X? So to find this, we have some one formula. You have to memorize this formula. Okay, resistance of the circuit. First, now we have to find the resistance of the full circuit. So in order to find the resistance of full circuit, we must find the voltage, the total voltage, that is 12, and total current, that is 1.5 in the circuit. What is the total current in the circuit? Is 1.5. So that is 8 ohm. Then the resistance of wire, what is the resistance of the total resistance is 8, and resistance of the lamp, what is the resistance of the lamp? That is 4. So the resistance of the circuit is 8 minus resistance of the wire is 4. So it is 4. I mean resistance of the lamp is 4, right? Because same value, that's why you are confused little bit, but no problem. So how to find the resistance of the wire is resistance of the circuit minus resistance of the lamp, right? Because lamp is only the one connected in the circuit, no other device, no other component. So for okay, now distance formula, learn this one. Total length of the wire multiplied by resistance of AX, you are finding AX, right? The one you are finding, you will keep it up, and total resistance of the total wire. So you know the resistance of the total wire is 4, I mean 5 is given there. You can see this one, AB is 1 meter and has a resistance of this, and resistance of AX, okay, is 4, and total length is 1 meter. So what is the distance of AX? It is 0.80 meter. Okay, in this question, look at this question, resistance R and length of wire. So you know the formula of resistance, resistivity. The formula for resistivity is what? The formula for resistivity is what? See here, R is equal to resistivity multiplied by length divided by area. So like this question, R will be directly proportional to the length, okay, and inversely proportional to the area, okay, directly proportional to the length and inversely proportional to the area. So you know R is directly proportional to the length. So they are saying resistance of, if R increase means length will also increase. So resistance A is cross sectional area, okay, A is inversely proportional. And now resistance, now they are doing RNA. So you know RNA is inversely proportional. So when R increase, A decrease. So this one here, see here, every same length and made up of same resistivity, So it means resistivity P will be also same and L will be also same. So we will not take this one. Okay. Now what we have to think is like, we have to do something like, resistance is given and what else is given? Hmm. Okay, resistance is given and 1 by A. A we have to find the ratio. Okay, and this is for 12 resistance. And what about the 4 1? 4 1 will also resistance is equal to resistivity multiplied by length. Length also nothing is the same, means 1 divided by area. Hmm. So 1 will be the 12 resistance, this one will be 1 by 12 and the downward will be 1 by 4. So your ratio will be what? Your ratio will be 4 by 12. So see in this one B, when the potential difference across the coil is at just U1.8 and the current is this one, calculate the how length of the wire in the second one compared with the length of the wire in the coil. Okay, in this question they are saying like how the length of the wire in the second coil compare with the length of the. Okay, now resistance is inverse directly proportional to the length, inversely proportional to the area. Okay, if R increase, length will also increase. Okay, so in this question potential difference on this is this and the current is this. Okay, length of the wire. Hmm. Okay, I will explain this question later. I have little bit doubt. I will explain it later. You know what is potential difference? Or this is frequency. This is power.